Hey guys, so in this video we are going to work on time series and forecasting in R. So before starting with the R programming, let me give you some theory on time series. So time series is basically a data on a single entity. So I'll just write uh, data on single entity over time. So this entity can be different things. So suppose I have a data of public debt over time and I'm just analyzing that data. You can say it's a time series data set. However, it differs from cross sectional. So when I talk about cross sectional, so suppose I have a data on GDP, then unemployment, and then inflation, and this all data set is for a particular year. So suppose this particular year is uh, your 2022 2021, and this type of data will be a cross sectional data because I have different variables but for a single year. However, here I have suppose public debt data set, and this data set is from 2001 onwards to 2010. So first one will be your time series data set and the second one will be your cross sectional data set. Now another thing is, in econometrics we actually say dynamic causal effect when we are working with time series data to find out the change in your dependent variable, or I can say your effect on y for a change in x over time. So basically, how does your dependent variable, so suppose your dependent variable is your guarantees given by the government, and it is changing based on what exactly is the consumption of different departments of the government. So over time, if I'm trying to measure this, so suppose from 2005 to 2010, I'm trying to measure how exactly the guarantees given by the state government to different sectors for borrowing loan is changing based on the requirement of different sectors of the state. That can be a dynamic causal effect over time, and it involves only one variable, that is your guarantees. Okay, so another thing I wanted to let you know is that there could be also other examples when we will be using time series data set. So suppose uh, government put taxes on your chocolates. So now if an economist is trying to measure the change in demand for chocolates coming due to taxes, he is going to use what? He is going to use overtime data on the prices of the chocolates, and then the demand for the chocolates would be your another variable. And in that case, what will happen? The economists will use your data for initially and subsequent years in order to find out the dynamic causal effect. All right. So I think that is all the theory you need to start with the time series, and I will cover the rest of the theory if required in the video. Let's begin with R now. So I'll just quit this and we will start with R. Here what I'm going to do is I'm going to show you exactly how we can use a regression model for forecasting. So I'll begin by calling a library. So library AER. If you have not installed this package or any other package which I'm using here by using library AER or library command, you need to put install.packages, then brackets and double inverted commas and the name of the library. Alright, so I am going to call this library now. I'll just run this. Now what I'll do, I'll call it dataset. from this library. So I'll write data CA schools. So basically this is a data set which is provided in the library, and I'll just show you how it looks like. So yeah, so I have different districts and I have the name of the schools in the data set. Then the country is given, grades given, student teachers are given, and then works, lunch, computer, other data set values, and then the subject English, read, and math. These are given. Now what I am going to do is I am going to see as a parent what would be my student score would be coming if I actually put him into some school with a specific student teacher ratio. So I have already seen the data set, and the first thing what I'm going to do is I am going to actually create a variable of student teacher ratio. So I'll just say schools, and I'm using this command to create a new variable which is str that will be having a student teacher ratio. So I'll say CA schools and the name of the variable students. Then I'll just say CA schools again and the name of the variable teacher, because I know that I'll just select this. This will create a new column. I'll just, so if you see here also, I have 14 variables right now. Once I run this, all right. So this should be C. This C should be, yeah. Let's run this. And if you see here, now I have 15 variables. I'll just show you the last variable we created. This is student teacher ratio. So basically what I have done is I have taken this column and this column, and I have calculated the ratio for it, because as a parent I want to see what would be the STR, and what using that STR I'm going to forecast my student like my child score. So I'll move to this back, and now what I'm going to do is I'm going to create the score also. So I'll write C schools, and I'll create a new variable which is score. And for this what I'm going to do is I'm using CA schools again, and I'll choose a subject that is read, and I'll add it CA schools dollar math, and I'll calculate the average for this. So there would be one more variable now, score. And if you see here, I have 16 variables. So I have now the student teacher ratio and I have now the score also. I am going to run a model on it. So basically the regression, because we want to see the regression model for forecasting. So I'll say LM and I'll say score here, and then I say STR. So basically what I'm doing is based on student teacher ratio, what could be the score? That is what my regression model is. And I'll say data equal CA schools. So I'll just get this and give me a second. This STR should be in capital. So it should run. Yeah, it is. Now what I'm going to do is I am going to present the result. So I'll just run this emoji and then I'll just see the results. So if you see here, I have an intercept and then I have a student teacher ratio which is negatively affecting the score. In this case, I have omitted variable bias also, because I'm only taking STR while I had so many other variables to tick through. But I just want to show you what exactly the forecasting will come up. So now as a parent, I can predict the value for my child score. So what I'm going to do is use this regression results, get me some new data which comes as a data frame where uh, str equals, so suppose I'll take str 25 in this case. So it says 641, and this is what exactly the predicted value which comes up. So if the student teacher ratio is 25, that is what my child is going to score, and I can use this forecasting model to vary with different student teacher ratio, and based on that I can decide, see, based on this I can decide in which school I have to actually put my child to see what exactly he is going to score, and I can also predict his next semester score with this model. All right, yeah. All right, so now we will work with time series and serial correlation. So I will install the required libraries. So I have quant mode here, and another library which I'm going to install is read excel. So these three libraries are required. First one is for econometric analysis, then second one, which is quant mode, it is used for financial quantitative modeling, and then read excel is used for reading excel file basically. So I'll just run this, and now what I'll do, I will create a data set because I'm going to import an excel file, and for that I'll use read.xlsx, and here I will give the path of the file I would install and then the other values. So let's see the file, and if I'll open this and I'll just increase size. Yeah. So this is my column 1, it does not have any name, and then I have some other columns which are count to 9. These are 9 columns which are numeric, while this one is text since it has the dates, and this is on sheet 1. Okay, so that is my data set. Now what I'll do, I'll press shift and right click and copy this as path so that I can put this in R, and now I will just add the path here. So I have added the path. I will just add the backslashes. So anytime you read an Excel file in R, you have to actually take the black slashes to double so that it does not create any issues. Otherwise, it's give you an error. Now, what I'll do, I'll just mention that my data is on sheet 1. And another thing which I'll mention is that my column types are, my first column is text. So I'll just write text, and then I'll say REP, and after this I'll say my other columns are numeric and they are 9 in number. So I will just run this now, and after running this, what I'll see is that my file has been already imported. I have US macro data here. Now what I'll do, I will just convert the date column into quarters. So I'll just say US macro data and the name of my first column, which is dot 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 1, and now I'll say s dot year quarter, and I'll say US macro data dollar, and I'll just give the name of my column again, and I'll say format this is y, percentage y I should say, because it's year, right? And then I'll say percentage 0 percentage quarter, not percentage, because percentage comes in first when I have to use years only. So it says US macro data, and let's run this now. And if you see, I have my data set now is in quarters, it's mentioned, but this does not look nice to me. So instead of this, I should have date here. So what I'll do, I will rename my columns. So I'll just say column names, and I'm renaming on my macro data set which I have. So I'll say use macro data, and now I will write down the names. So I'll say this one is date, then next one is my, I will keep the name of other variables same, just showing you how exactly you can just have different column names. If you want to change, you can change the names of the column using this command and having it here. I'm just using all of them same. So next one is my PCE CTPI, and then I'll say this one is GS10. I'll just bring it to next line and I'll say GS1, and other column names are here. So I'll use TB3MS, and then I have UN rate, which is basically unemployment rate. Then I have EX US UK. This is basically the exchange rate I have. I'll just do this and this. Now what I'll do, I'll just add the last name of my column, AUCSL. I'll close this. Alright, so I have just named the columns back and I will run this now. Now that I have new column names and I have my data set, I'll just have a look at it once, and yeah, I have date written. Now what I'll do, I'll just extract the value. So what I'll do is I'll extract the GDP data from it, and then I will calculate GDP growth rates, and we will have a plot also to see this. So if you see my data set, I have it from 1957, and but the values for this column is coming from 1959. So I don't want any value. So what I'll do is I'll take it from 1960. From 1960 till which date I have the data set. Let me just see. So I have till 2013. So I'll fetch GDP data from 1960 to 2013. So I will write GDP, and then I will use XTS. XTS is an R package basically. It is designed for working with time series. So I will just write the name of my data set now, and now I will say this column needs to be fetched, and with this I also need the date column. So I'll say date, and here I will mention the range. So it's 1960 to 2013. So I will fetch this now and will run this. So I have the GDP data now, and if you want to see, you can see also I have GDP here, and if I click, you can see that from 1960 I have fetched the data set. Alright, next what I'll do is I will take GDP growth now. So I'll say GDP growth, and for this I will again use the XGS package for working, and I will do 400 into log GDP, and then I'll say lakh GDP. Alright, so I have actually used 400 here because I'm founding it for annual growth. Otherwise, we could have used the 100 here for quarterly growth. Alright, now I'll just run this, and I have those things. Now I have GDP, and I have GDP growth, I will just plot this. So to plot, I will use plot function. Then I say log s dot zoo. So s dot do is a function from zoo library, and now I will say GDP, and this column is closed, this column is closed. I'll put comma here. Now I'll move to next line. I say color equal red, and I will put a comma. I have to put comma here. Now I'll just delete this. I'll move this out, and now I say line width equal 3, and I will again put a comma because I have to add more things. I say while lab, that is your label, so I say logarithm, and 1 second, logarithm. And now what I'll do, I'll put a comma again, and I'll x the x label, that is your date, and again put a comma, and now I'll write down the heading of my graph. So I'll say US quarterly real GDP. Now I will run this, and if you see, I can actually have a look at the growth rate and GDP, how exactly it is moving over the quarters for United States. Next, what I'll do, I'll just add a GDP growth also. So I'll use plot as dot zoo, and then I will say GDP growth. Now what I'll do, I'll put a comma here. I say column equal red, and I'll put a column again, and then I say line width equal 3. So I want a darker line in red color. I say y label equal, again I'll say logarithm, and then I'll say x label, this should be next line, x label, and this equals date. And now I will have the title for this. So I say mean equal US real GDP growth rates, and I will run this. So if you look here, US real GDP growth is not very high as compared to what I see when I look at the quarterly growth of GDP. That is because real growth rate is always deflated by prices. All right. So all right. So before moving further with time series analysis, let me give you some theory of it. So there is a concept in time series which is called lag. It means that the values are lagged behind in years. So suppose I have a value of GDP in year T, and again if I have value of GDP in year T minus 1, that means I have my first lag value. So basically the value goes to the previous year. So if I have yt minus 2, that means the value in year T, and then the value 2 years back in time period, that is my lag. So this lag can be first lag, second lag, third lag, 10 lag, whatever you put after t minus number, that number will be your lag previous value. So it is also important in time series to understand this, because sometimes we work with the difference equation in time series. So if I have some value in period t and I have yt minus 1, that means the value in the previous period, then I will say this is my first difference equation. Similarly, I can have my second difference equation if I put yt minus 2 here and I calculate the change in yt. All right. Also, an important thing is in time series we work with the logarithmic data. So like we actually put a log to our equations so that we have more consistent and better results, and they are standardized also. So in that case my equations changes to log yt, and I'll say log yt minus log yt minus 1. So basically what I'm doing is, instead of directly looking at my first difference equation, I will log the variables and then I look at the difference equation. And in this case you just need to remember that your y is obtained using a formula which is log of y, that is your variable, by lag. This is not log, this is lag y. Okay, so that depends what lag value you are taking. And in order to get the hand of it, I use 100 log yt, and this will be an approximation basically for the for percentage change between your yt and yt minus 1. So basically what I'm trying to say here is, this is your first lag yt minus 1, but sometimes we work with first difference equation, so we use this. Also we use log in time series, so my equation changes to this. And in this equation, when I have to calculate your yt, so earlier we were actually calculating change in yt using this yt minus yt minus 1, but in this case we actually use log of y over lag variable. So lag variable will be your yt minus 1 if you are using first difference, so y divided by yt minus 1, and I am taking log of it. And if I multiply this with 100, then it will show me the percentage change. So this one is about your economic series. So economic series uh, usually grow exponentially. Suppose the trade openness, exports and imports, or probably just exports of a country, they rises exponentially. So what actually happen in this case is, when we have an economic series, we use log. Why log? Log is basically give us approximately linear results. So that is why with the economic series we use log. Also another reason is standard deviation. Standard deviation of the log for this kind of series is constant. So when standard deviation is constant, there is not much variation also. And most important is, we report growth rates in macroeconomic terms. So when you report growth rate in macroeconomic terms, it gets important to actually log the exponential economic series and obtain the results. So that is why we use log in time series. And this log is also used in panel data just to get the result which looks much more linear. And alright, so before moving to serial correlation, let me give you some theory behind. So whenever we work with the time series data, the observation are generally correlated, and this type of relation between the observation which is happening over period of time from yt to yt minus 1 to yt minus 2 is called autocorrelation. So if I have to write this in terms of econometrics, I'll say jth autocovariance. What will that be? So I'll say jth autocovariance would be covariance between your yt and yt minus your jth observation. So jth autocorrelation formula in econometrics will be your value, and I will write yt comma your values in yt minus j. So this will become your covariance yt yt minus j. So I have written the autocovariance in the numerator, and then in denominator we will write your variance yt minus j. And this P over here which you are seeing is basically used to represent autocorrelation. Basically it is rho, and it is used to write down your autocorrelation in your time series data. Alright, let's go to desktop now and work on R. So I will just quit this and we'll come back here. Now we will start working with time series and serial correlation. Alright, so next what I am going to do is I am going to create a function to calculate different statistics which comes up in time series. So in order to create that function, I'll say quants, and now I will write function, and in bracket I'll write series. Now I will open this, and here I am going to assign the input series to a new variable for manipulation. So what I'll say series, and now I'll create a data frame so that this data frame can contain different statistics for the series. So I'll say here return, and in return I'm going to write data frame level and the original series. So I'll say data frame, and I'll say here level, and now above I have given the series as S, so I'm going to write S as my original series. And next what I'm going to do, I'm going to do a logarithm of that series. So I need the log value, so I'll say logarithm, and then I'll say log of my original series. One second, this has to be here. And after this what I'll say is I want the annual growth rate. So if you remember, for quarterly growth rate I multiply with 100. For annual growth rate I should multiply with 400. So I'll write annual growth rate equal 400 star, and here I'll say log my original series, and then I'll say lag of my original series back. And again this inverted comma need to be for this text, so I'll put it here. And now the last thing which I'll do is I will say first lag of annual growth should also be with me. So I'll see first lag annual growth rate, and for this I'll put the formula which is lag 400 into, so basically what I'm doing is I'm calculating the lag of my annual growth which I just calculated above. So I'll just write lag in bracket, I write S, and then I will just close this, and after this I have my curly bracket. So I'll just run this, and now I have created a function which is going to do all the different statistics I need to do for my time series data set. Now what I'll do is I will calculate and display the statistics for GDP, and I will use data from 2011 to 2013. So I'll say quants. Now quants is actually going to work for me. So just take my GDP from the data set and use 2011 07 and 2013 01 values. Now I'll just run this, and now it has taken the values for me. So I have the level, I have the logarithm annual growth rate, and my first annual growth, which I just wanted to find out. Okay. So next what I'll do is I will calculate and display the autocorrelation for GDP growth rates. So what I'll do is I'll run ACF, and ACF is basically for finding out your autocorrelation in time series. And I say any omit, so it should not take my any values. And I'll say GDP growth. This should get closed here, and I say lag it to maximum 4 points, and then I'll say just plot this as false. So when I say plot false, it should not plot anything for me. So I have got the values. Now important thing to remember here is, if you get average of all these four values, these values is actually growing faster than average for any period, then there are very high chances that you have some serial correlation in your series. Okay, so that is how it is done. And next what I'll do is I will plot additional economic time series data for you, so that you can actually have a view how different economic time series data sets look like. So we will use the same Excel file and plot some functions. So I will first of all begin with the US unemployment rate. Alright, so I'll write US UNEMPL, that is for unemployment rate, and I again use the XGS package. I'll fetch the values from my macro data for the variable UN. It should come, yeah, UN rate, and then again my other column, which was basically the date, and I'm going to fetch it for 1960 to 2013. All right. In addition to US unemployment rate, I will also put Japanese industrial production data. So I say Japan IND, and I'll write production. Yeah. So I will again use XTS package, and then I'll say you should log it because the production will be very high. So I am just using log and showing you how exactly you can do log also while running the important codes. And then I'll say US macro data dollar date, and I again will let it know that you need to actually fetch this for this should close in 1962 2013 only. So I'll just copy this value and then I will add it here. So again, if I run these two, I have US unemployment rate now stored in Japan industrial production also. Next, what I'll do, I'll also show you how exactly the US dollar exchange rate with British pound. So I'll say dollar, pound, and then I say exchange, and I will again use XTS. Now I have to fetch the exchange rate data from my dataset. So it was EXU, this one, and then I actually need the dates and the same information which we were getting earlier. So I'll just say macro data dollar date, and again I will say 1960 to 2030. Next, what I'll do, I will also plot New York Stock Exchange Composite Index. So I'll say data, and here I will write down the name of the dataset, and this dataset is coming from your AER library. So I will fetch the dataset, and then I will actually tell R that I want to use time series on it. So I'll say XGS, then I'll say DELT NYSESW. Alright, now I'll just run this. Just to let you know, there's this DELT is actually calculating the percentage change between consecutive numbers coming up in my numeric vector. So basically my data set has some consecutive numbers. It is going to calculate the percentage for it, since I have a plan to plot this. So now I have my 4 economic series data set. So I'll just set the plot layout, and for setting that I'll say PAR, and I'll say MF row, and I need 2 by 2 column. So basically 2 rows and 2 column, and now I have my 4 graphs. So it should be like 1 2 3 4, the way a quadrant look like. So I'll begin with plotting the US unemployment rate first. So I'll just say plot as dot zoo, and then I say US and what I created above. Then I am going to write down the different values. So I'll say again the color should be red for me, and my Y lab should be logarithm, and now my X lab should be equal date, and then I'm going to write my main should be the basically the name of the graph which comes at the heading on top is should be unemployment rate. And here what I'm going to do is I'm going to control the size of the main title also, so that it doesn't look very big, because I have taken the 2 by 2 space and I have declared the plot layout. So I'll say cex dot main. Now it will control the size of the graph I'm going to plot. So I'll just have done this, and now I will run this. It says your figure margins are too large. So what I'll do is I will just zoom out some size, and now it should plot this. So I have it here. So basically the size of the plot was not working for us. Now what I'll do, I'll also forgot to add some thick line here. So I'll do, that's why it has taken a very light red line. So I'll just add the line width also, and I will again plot this up. So if you see here, I have a good line width now. So I'll just delete all the plots and run this one only. And yeah, now what I'll do, I'll just let it know again that this has to be like this. All right. So now that I have US unemployment rate, so if you see it, it's basically showing me that during recession years, the unemployment actually went very high, and during economic growth, the unemployment was less. So that is consistent with the economic theory. I will move ahead and I will just plot the US dollar and British pound exchange rate basically. So I'll just say here plot, and then I'll say as dot my zoo function, and then I will write here dollar pound, basically the function which I created, that is exchange, and I just write color equal here again I'll say red, and then I say line width equals 3, and then I say my y label should be dollar per pound. So I'll just move it next, and then I say my x label should be equal to date. And now what I'll do next is I will give my mean here, so that is going to be US dollar by British pound exchange rate. And now what I'm going to do is I'm again going to collapse some sides for it. So I say CX mean should not take space more than 0.8. Now I will plot this. Alright, I got my result. Let me zoom it for you. So basically it is showing me that the exchange rate when it was actually pegged. So in the Bretton Woods system, it used to be very fixed. At that time, it was quite consistent with the economic theory. And then in early 1970s, when the Bretton Woods system collapsed and then the exchange rate was allowed to be flexible, I see the variations in the exchange rate, which is again consistent with the economic theory. So I will move to next, and then I will plot the next figure, which is going to be the Japanese industrial production for me. So I'll say plot as dot zoo, and I'll say what I created for Japan. So I'll take this, and then I'll just move next. I say color should be red, and I'll say line width should be equal 3. Then my y label should be equals to logarithm, because I am going to log this. I have already used the quant function, and then my x lab should be equals to, let's say, date. This has to be in inverted commas. Also logarithm needs to be in inverted commas, so I'll just add that also here, and I just put this, come down, and I'll put this, and this has to be like this. Here I need to add now my main, so I will add my title, that is going to be Japanese industrial production, and I'm going to put a comma, and now I'm going to add my main title. So I say 6 mean is equal to 0.8. So I just, and now I have my Japanese industrial production, which basically is increasing from 1960 to 2000, which is again showing an upward trend, is consistent with the economic theory and the reality also, I will say. Now next what I have to do is I have to plot New York Stock Exchange Composite Index, and this index needs to be like something which is going to show me the volatility clustering, which I say in economic theory. So let's see, I'll just plot this and see how exactly the financial time series look like. So I'll say plot s dot zoo, and now I will write nysesw, the name which I have given, and now I have to give the color, which is again I'm giving red, and next is I will say LWD. This time I'll also give 3, and next I'll say y lab should equals to percent per day, and your x label should be date. I say mean equal ny stock exchange composite index, and now I'll just say cx equals dot main equals 0.8, so that it does not take much space, and I'll just run this. It says so give me a second. So if you see here, I don't have to actually put this in inverted comma, so I'll just delete this, and now I will run everything one more time. So I have the graph now, and if you see here, the New York Stock Exchange Composite Index, that is basically showing me volatility clustering in terms of economics, which is very common for your financial time series data. The values are not moving much, but they are actually coming back to the line at 0, and that is how it is actually showing me the high and the low periods of variance, which is very common. All right. So next what I'll do is I will plot the correlation function for the similar data set. So what I'll do is I will write na omit, and I will do it for this data set only. So I'll just write this name, and then I'll say plot, and I'll say false, so that it should not plot it right now, but lag it to maximum equals 10. Now next what I'll say ACF. Now I will do a plot, so I'll say ACF na dot omit, and after it has done my lag, it should plot this as mean, and it should write this has to be in inverted comma sample autocorrelation for NYSESW data, and I'll just close this. So here I have, okay, I have to give the name of the dataset also here, so I write NESW. Okay, and now I can run this. So I'll run this first, and if you remember, we have to calculate the average value here for all these values, and then we have to see in if any period this is rising beyond average, there is a possibility of serial autocorrelation. Now I will just run this. Okay, it is NESW, so I'll add W also, and I'll run this again. Now I have my graph. So if you see this, I have blue bands here which are actually representing that beyond this there would be autocorrelation, and anything at any period I see few times it is going beyond the blue bands. So that means there is a autocorrelation at this point of time that is significantly above 5%, or I can say different from 5% level, but that has happened only a few times, and that is very common when I actually see the financial times series data sets, because sometimes the values of the stock varies a lot. in a single day. So yeah, that is what it is showing, that the autocorrelation actually exists in this type of data set. Alright, so yeah, that is what we have covered today. So we have worked with the time series data set, and we have seen how exactly different economic time series looks like and what exactly the tactics to handle the economic time series data set in R. We always have to go for the linear results, so we actually log the series most of the time. Alright, I think that is all for this video. I will cover the other important parts in the further videos will be coming on your time series in R. So stay tuned and thank you.